Earlier this week, an NVIDIA agent scored a perfect 100 on one of the hardest reasoning benchmarks in existence. And here's the twist. That agent was never built to solve puzzles. It was built to write GPU kernels. The agent is called AVO. On August 21st, NVIDIA published the result. AVO hit a perfect 100.00 on the ARCAGI3 benchmark. It completed all 183 levels across 25 different environments, and it did it with 12% fewer actions than the previous best agent, VISTA. But the number that should stop you cold is a different one. AVO runs on Claude Opus 5. That same model, pointed at ARCAGI3 by itself, with no agent architecture around it, scores 30.2. Wrap it in AVO, and it scores 100. That's a 3.3 times multiplier from the system alone. So what is ARCAGI3 exactly? It's an interactive reasoning benchmark. The agent walks into game-like environments with no instructions, no rules, and no stated goals. No multiple choice, no fixed context, no single correct answer. The agent has to figure out how the world behaves purely by trying things, observing, acting, learning from the outcome, and building a mental model. The score measures efficiency compared to humans. 100 means the agent matched or beat human performance. One important caveat, because it matters. That perfect score is on the public set of levels. The private evaluation set, the real test of generalization, hasn't been published yet, so call it a very strong signal, not proof. But the architecture behind the result is worth understanding. AVO stands for Agentic Variation Operators. At its core is a loop with 4 phases. Inspect the current state, plan the next move, implement it, then evaluate what happened, then start again. 2 things make it different from a basic agent loop. First, persistent memory. Most agent systems forget everything between calls. Every prompt starts from scratch. AVO remembers. It keeps a lineage of past attempts, a knowledge base, and feedback from its experiments. It doesn't repeat the same mistakes or re-explore dead ends. Every cycle builds on the last. Second, a supervisor. A separate process watches the agent's overall progress. When things are moving, it stays out of the way. When progress stalls, it steps in and redirects. It's the difference between an agent that gets stuck and an agent that recovers. Now remember the origin story. AVO wasn't made for ARCAGI3. It was made to autonomously evolve GPU kernels, specifically attention implementations on NVIDIA hardware. In a 7-day continuous run on DGX B200 systems, it explored more than 500 optimization directions and committed 40 kernel versions. The result, kernels up to 3.5% faster than cuDNN and up to 10.5% faster than Flash Attention 4. And that's not even the full story of the original run. After the 7 days, NVIDIA took its evolved multi-head attention kernel and adapted it to grouped query attention, a different architecture entirely, in just 30 minutes of additional autonomous work. That variant landed up to 7% faster than cuDNN and 9.3% over Flash Attention 4. Then the reasoning benchmark. NVIDIA took that exact same architecture, memory intact, supervisor intact, and pointed it at a completely different problem. No redesign, no special casing, and it hit a perfect score. And VISTA was designed specifically for ARCAGI3 style reasoning. A purpose-built specialist, and AVO, a kernel evolver, matched it on performance while using fewer actions. That transfer is the real story. Most agent systems are purpose-built. AVO suggests the architecture captures something more general about autonomous problem-solving. Which points to a bigger shift. The frontier is moving. Raw model capability is getting commoditized. The competitive advantage is in the architecture around the model, how context is managed, how memory persists, how supervision keeps the agent on track. 3 takeaways. 1. A model benchmark and an agent benchmark are not the same thing. 30.2% is not what that model can do, it's what it can do with nothing helping it. 2. Persistent memory is what makes long horizon work possible at all. 3. Supervision is what turns a competent agent into a resilient one. The frontier in autonomous agents isn't about bigger models anymore. It's about better systems. And the public set result from AVO is the strongest hint yet. When you build the harness right, the same model that solves one problem in a third of the cases can solve an entirely different one, all of them. Full breakdown, sources, and links are in the research post on ThinkSmart, Life.